we see question 1 for section 4.3 on Newton's third law of motion. A 40-kilogram boy pushes his 33-kilogram brother with 20 newtons of force. How much does each accelerate? All right, well, we have our two masses here. So here's our first mass. Here's our 40 kilogram boy, and his 33 kilogram brother. We'll call these guys M1 and M2. Now they both experience the same force of 20 newtons. So here's what we know. The force that each one receives is 20 newtons. One to the left, one to the right. M1 is 40 kilograms, and M2 is 33 kilograms. Now, to get the accelerations, we have to use Newton's second law of motion. Force equals mass times acceleration. I don't know why the screen did that little weird thing there, but that's all right. Divide both sides by the mass to get the acceleration by itself. Acceleration is the force divided by the mass. So if we want to get the acceleration of mass 1, we're going to divide 20 newtons by 40 kilograms, and that'll give us 0.5 meters per second squared. To get mass 2, 20 newtons divided by 33 kilograms to get 0.6 meters per second squared. On to question 2. A 35-kilogram boy pushes against a 5,000-kilogram wall with 100 newtons of force. How much does each accelerate? This problem is virtually identical to the previous one. We have our two masses and our singular force. So both the boy and the wall experience 100 newtons of force. It doesn't matter which one we call mass 1 and which one we call mass 2. I call them mass 1 and mass 2 just based on the order they appear in the question. So using our previous formula, acceleration is force divided by the mass, we can figure out the acceleration by dividing the force by our two respective masses. And our third and final question, a 25-kilogram block accelerates at 2 meters per second squared away from a 30-kilogram block. Determine its acceleration. Now, this question is a little bit more difficult because we're asked for the acceleration of this mass. So if this is M2, what we're looking for is A2. We've got up here mass 1 and acceleration 1. Force is mass times acceleration. So 25 kilograms multiplied by 2 meters per second squared gives us 50 newtons of force. Now that 50 newtons of force is the force that the 30-kilogram block is receiving. So the acceleration of mass 2 is the force that we just found divided by mass 2. Plugging in, that's going to be 50 newtons divided by 30 kilograms, and we're going to get 1.7 meters per second squared. Notice that the force is the same between the two objects. That is Newton's third law of motion.